So here's this question that you guys started yesterday. Ethan and Cameron, I'm gonna post it up online because I forgot to record it, so you guys can see a couple things. Okay, so yesterday we had to do what with this?
Put it into our calculator.
We had to put it in our calculator. Why? Oh. We had to enter it in because they gave us data. Okay, now, what did we also talk about yesterday when I said they're not going to tell you what? They will never say what to you. Yes, it's never going to say perform a significance test. It's always going to say, does it have evidence? And remember what I told you. You are collecting evidence to support the alternative hypothesis. So we did also write the first thing down, right? Yesterday I put the population mean, right? Is that what I put, the population mean, or did I put the population or the mean of reading time for GG font? And then I wrote the null hypothesis and the alternative hypothesis. And then we also stated the alpha level. They didn't give us the alpha level, so when they don't give you the alpha level, you need to pick one. And remember, 0.05 is a good medium one. That is also, remember, the alpha level is also the level of the probability of committing a type 1 error, okay? So now, we also talked about what type of test that we were going to perform. And what type of test is this?
One sample Z test.
It is a one sample Z test. Why is it a Z test?
Is it sigma?
Because they gave us sigma. So it's a one sample Z test because they gave us sigma. And then you could use a t test, but because they gave us the sigma, we're going to use a one sample Z test. Okay. Now, we talked about the three conditions. So what are the three conditions of any significance test, any confidence interval? What are the three conditions again? SRS. So before we go on, let's talk about SRS. Is this an SRS? It is not an SRS. It is not stated anywhere in the problem. All it stated is that there's 22 adults, right? No, 25 adults. So I'm just going to show you what I picked. So yesterday I put not stated in the problem. So I started working this problem out, and this is what I put. Not stated in the problem, ask 25 adults. We will assume... and then I put caution, and you guys can't see that, so I apologize. There we go. So I put caution. You guys could have put not stated in the problem, proceed with caution. I put we will assume just because in order to proceed, we have to assume that it was an SRS. It doesn't state it in the problem, so when we get to the conclusion, you guys, we're going to talk about the SRS, okay? Now, because they gave you data, what do the next condition, what's the next condition? Normality. Okay. It does not matter that they said it in the problem, but they gave us data, so what do we have to do, no matter what?
Box plot.
You have to draw a box plot. You guys, it doesn't matter. They gave you data, so you always have to draw a box plot. Always. Okay? And then it is stated in the problem, right? Stated in the problem, suppose that the reading times are normal. Data given, you need to draw a box plot. So I didn't draw a box plot, but you have to. So you can put stated in the problem, suppose that reading times are normal. Data is given, so you don't have to write data is given, but you need to draw a box plot there. You have to draw a box plot. Does not matter. They gave you data. There should always be some type of graph for your data. Okay?
Yeah.
Next thing. Okay, so we've done our two conditions. So at the box plot thing right here, you should have a box plot. Now, you also need to discuss the box plot. Like, is it symmetrical? Are there outliers? Okay? So make sure you have some type of description of it. Now, what's the last condition? Independence. And independence is what? What? Population of,
Oh,
yep, is greater than your sample times 10. And so in this case, is the population size of adults, right? Is that greater than 10 times 25? So is the because you guys, our population is adults, right? So is our population size of adults greater than 250?
I hope so.
Yes, 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 yeah. Okay. Now, I've already told you it's a one sample z-test. You also want to mention, is it a one sample, is it a one-tailed test or a two-tailed test? And how do you remember, how do you say if it's one-tailed or two-tailed?
Well, if it's two, it's the unequal, so you can look at either direction.
Yep. So this right here, your alternative always tells you if this is a not equal to, then it would have been two-tailed. This is a one-tailed. So I write it down here. It's a one-tailed z-test. We know sigma. That is why. And notice, you guys, when I put it's a one-tailed z-test, we know sigma. I put it. Why did I use it? Because we know sigma. Now that not maybe you need to know that, but I wrote it down because, of course, I'm the teacher, and I wanted you to make sure you knew why we use the z-test and not a t-test. Now, notice I'm missing a couple things. What am I missing? What don't I have that you guys should have by now? I have sigma because they gave it to us. I have n. What don't I have? X bar. You need X bar. You guys, you are going to figure out X bar because you were given data. Also, if I can borrow someone's calculator, I'll show you how to do the z-test because, again, my calculator is broken. Okay, so here we go. It's a one-tailed z-test. That means, you guys, when we draw the normal curve, you're only going to have your p-value in one tail. So we're going to go to stat over to test. Yours would just be the test. Okay, and look, the very first one you get is a z-test. Now it's going to ask you, your calculator asks you, hey, do you know data or do you know stats? Well, if you put stuff in your list, that means you know data. Okay, and then what did they say the mean score was? What did they say it was? What was the mu? 22. We say that if you read GG, it's going to take longer, right? And what was our sigma? 6. You guys, if you were in a t-test, okay, listen to me. If you were in a t-test, sigma would not be there. You couldn't, you'll know. The nice thing about the calculator is you'll know if you're in the right test because you'll have the information for the correct test. And then where did you store your information in?
This one.
Okay. We stored it in the list 1. I like how we said we. I don't know where you guys stored yours. Make sure you put in the correct list. Frequency is always 1. And then what is our alternative? Did we say it was equal? Did we say it was not equal to 22? It was greater than 22 or less than 22? So we're going to pick the one that says greater than. And then hit calculate. Now, here is something you guys need to remember. Do you see your p-value? It says 4.680790. That is not your p-value. Your p-value actually has 4 zeros in front of that 4. Your calculator put it in scientific notation. I'm going to tell you, you will lose a point. You guys, out of 4 points on a free response question, if you write your p-value like this, -1, I would rather you lose 1 point for not. So let me tell you about points. If you don't write a conclusion, you lose a point. Okay? So you can do a whole significance test and say, I have no idea how to write that conclusion, and you'd miss a point. Okay? That's a good point. Like if you forget it, you're like, I don't know how to do it, you miss a point. Good point. But if you don't write your p-value in the correct form, you lose a point. Do you guys see? Like you just lost 2 points. And this is something that you shouldn't have to lose points on. So remember, that's in scientific notation. You're never going to have a p-value that is bigger than 1, the number 1. And you shouldn't have a p-value that's bigger than 25. If you have a p-value that's bigger than like 25%, like 0.25, it's probably a two-tail, okay? So let me show you again how you would write that p-value. Notice I didn't write it. So my p-value, can you see that? No. And it's to -5, right? So that means you have 1, 2, 3, 4 zeros. And it's going to be 5. Okay, so now we're going to take that p-value and we're going to compare it to our alpha level, okay? So is our p-value, how is our p-value related to our alpha level?
Smaller. So
Right? So would we fail to reject or would we reject? If your p-value is smaller than your alpha level, we're going to reject the null hypothesis. Okay? So now let's talk about how we would write the conclusion. Now, do you remember what I told you guys? I said if your p-value is less than 0.01, what can you use? Strong. Okay, so here we go. We reject the null hypothesis in favor of the alternative. Okay? There is strong evidence to support the claim that the true mean reading time for GG is greater than 22 seconds. Yes.
what would you put?
So the question was, what if you can't write strong, what would you write? You would just say there's evidence. When it's less than that 0.01, that's when it becomes strong. However, there's a problem, right? We proceeded with caution. Why did we proceed with caution? Right. So then now we need to say that. We need to tie it back in and say something like this. We need to verify, or we need to make sure, because we assumed that this was an SRS. We need to verify that this came from an SRS so that we can use these results, right? But you need to connect it. Like, this is fine, but you're going to lose points if you don't say something about the fact that you proceeded with caution in SRS. You have to make sure that you always connect. Okay. Now, I do want you to know there's a couple things that I left out here. You always need to write. You should always write the test statistic formula. And we did this before break. We were talking about the test statistic, and the test statistic would be. What was the X bar? Didn't they give you the X bar? So it would be -22. and it would be 6 divided by the square root of 25, and I forget what this is right here. You always want to put the test statistic, like you always want to write it out. You guys, they're going to give you the test statistic when you use your calculator, but you always want to make sure you write it out. And with that being said, go ahead and pack up.